Alright, boys. What's going on YouTube? It's your boy, Wonder. Ladies and gentlemen, I'm coming back with a video showing us, or showing you guys, how to read GDB or read registers. This is necessarily for users that's using either low level, meaning using a program that can talk to assembly language, which are usually C++, so that's what we're going to do. Alright, I already have a file that has a bug. I'm going to open it up, right? As you can see, it's in the name. This file right here has a bug. This is what I'm coding right now. It's let me tell you something about this program. So what's going to happen is I'm passing a string to a couple of functions. This program is basically performing bitwise operation or bitwise logical operation, meaning is going to is going to pass a string, a memory string, right? It's going to pass a memory string or any types of string. It could be binary string, and it's going to basically break it down. So it's going to turn the memory string, like a hexadecimal string, into binary. Then it's going to perform, depending on what you want it to perform, an AND operation, or exclusive, or arithmetic arithmetic shifts, like shift right or shift left. So basically that's what this whole program is about, as you can see. So the the what do I want to say, the bug, right? The bug is in this function right here, which is called hex hex to binary, H to binary converter. That's what it does. Takes a hexadecimal and converts it to binary, and then we're passing the hexadecimal string to the function. So I will be supplying you guys this code in the link in the description. You can do whatever you want with it, follow along while I'm breaking this down, and you guys will see the bug. So this probably isn't the best coding practices at all, mind you. I'm new to coding, fairly new, especially with C, and this is like my third month coding with C. So this is the unions, and we're passing a whole bunch of, we're copying a whole bunch of strings to each set of union. We loop through a string that gets passed to the union, which should honestly be, yeah. We loop through the string, and if zero, we return that to zero. This really doesn't matter right here. You don't have to worry about that. This is where our string is passed to, with right here, and we're looping through, as you see, and then we use a switch statement. So yeah, we're going to be looking at this, and here. All right, so let's get to it. Let me see. We exit that. We could go GDB. So this is what we're going to do. The first thing, right? What's the first thing you do? It's going to load you into GDB. This is GDB. All right, we're in GDB. If you don't know how to install GDB, if you don't have GDB, I don't know what to tell you because I'm not going to show you. So you better figure it out and do it on your own, and then come back to this video. All right. And you have to be a Linux user to use GDB. All right. So yeah. First thing we type is layout next. First thing we type, we're going to be able to see memory, hit enter. Now we see our function. But instead of saying break at the main function, which is on line 268, we want to break, right? We want to set a breakpoint in the main file, but on a certain line. So to see that certain line, before, don't hit enter. Do not hit enter. I mean, yeah, don't hit enter when you're typing. So All right, let's close out of this, right? We're gonna go back into it. So we starting. So we first thing we type is layout next. All right, hit enter once. Now we see our line. I mean, we couldn't just scroll up here instead of breakpoint, but what I was gonna say is just keep clicking, and now you got the full picture here, and then you can just scroll, set a breakpoint at like 10. Let's set a breakpoint at 57. So, right, break main. We're gonna do main. We do the file, and then type 57 for the line. Hey, yes. Okay. I don't know what went wrong. Okay, refresh that. Yeah, that's bullshit. I'm gonna be honest. I see I'm messing up. I don't know why it's not working how I want it to work, but let's go back in it. Layout next. Break the main.c 57. We don't have a source file called main.c. Okay, that's the issue. Our file is not called main.c. So we set a break union underscore bug.c. You can change the name if you really want to. Alright, for this instance, what I'm gonna do, I'm gonna change the name to it. How do I change the name? I don't know how to change the name. Mm, yeah, fuck that. I'm not changing the name. If you guys know how to change the name, that's good for you. Change the name. I don't fucking care about changing the name. I'll keep it real. So now we're actually in a video. Breakout next. I mean layout next. Let's say break union bug.c. I hit tab there. I didn't feel like typing the full thing, so I hit tab and it completed. And then we can say line 57. And now we hit R for run. Okay, yes. And now we hit refresh. Boom. Boom. All right. If you guys do not know how to read memory, I advise you the first thing you should do is, right? I advise the first thing you should do, we're just gonna go through, hold on 1 second, scripts, projects, CD into byte, shifting, CD into, alright, I advise you to do this. Let's do assembly, we do touch, we do assembly, dot txt, because you're gonna want to break this down if you don't know what it means at all. Like if you have no context of anything in assembly, you don't know what anything is, you're gonna need this. Okay, so the first instruction here says move, right? Move L. If you don't know what move L is, so what you can do to learn how this works is we say print. I mean, no, this is string copy, right? That's what the string is. Yeah, string copy. So we do string copy. Then it says hex bytes. And then guess is 0 byte. And then we're copying this into that. Okay, so, and then you can say this is on line 57. So that's the first line. And then we say assembly commands or assembly or GDB commands, assembly code as you feel. Oh no, no. First off, so we don't do that. Now, right, what I say. Okay, there we go. So the first instruction is move L, and then there's some form of constant. Okay, so move. This is like describes a constant. Yeah, describes a constant. Constant being I don't really know how to explain this. Okay, so and you just look it up in assembly. It should come up. The dollar sign assembly basic syntax. Wikipedia. Rubber uses memory uses a memory for instruction. To key also to register. Hmm. Google will help better. I'm gonna be honest. The only reason I use DuckDuckGo is because I have to actually look for things, which is pretty smooth. It's been going pretty well. Used to represent current address counter. The counter. I don't talk about. All right. So it says move, and then it has a hexadecimal, right? Notation of 30, 30, 30. And then I think it's saying move that into, okay, we're moving that into what? Oh no. How we're moving that into here. We go here, go there, then we go here. That's how you break it down. Okay. And now, if we want to understand what this does, with this move L and then this hexadecimal representation into the base pointer, and then if you don't know what this means, I will explain it. So, okay, let's do it right now. So the first thing you want to do is we can examine what's in the base pointer right here, what's in the base pointer, and then you can honestly you can see what this is, okay? So we can print this as a string. You can see obviously we have a string right here, but we can print this as a string, and then we can see what's in that before we actually do the move and draw instructions. So everything we're going to do is before. So this is before, so let's do, you type examine, right? That's what X stands for, examine, and then we do examine string, and then we do 30, 30, 30. Okay, value can be converted to an integer. Let's say print the string. I don't even know. I'm testing things. 30, 30, 30, 30. Void. Okay. This is how you really want to do it though. Believe it or not. If you're, I'm fairly new to even learning assembly too, okay? So if you're new, you just want to test things, see which works. So I know this, we can examine this hexadecimal presentation first. We can examine it first, so let's just go to examining what's in the base pointer. Okay, so we do examine 4 hexadecimal bytes. Okay, 4 hexadecimal bytes in the base pointer, right? So we specify that it's the base pointer with the dollar sign coming before the base pointer, and then we do so. Okay, here's the catch with negative OXD stands for. It means subtract OXD from the base pointer, which is where the hexadecimal presentation will be moved into. Okay, so that's basically all it is. Good, that's all that's going on right now. So we see here when we examine it, the base pointer that's below, that's the base pointer that is OXD below. I don't know what OX, so we could say, let's say examine or print the decimal of OXD is 13. So the hexadecimal presentation, 13 bytes below the base pointer. This is what sits in there, okay? This is what's sitting in there. So we can go back to our notes. Go back to our notes and we say examine, right? Examine the base pointer, which is OXD, which is 13, because D is 13. A, B, C. A is 10, B is 11, C is 12, D is 13. So 13 bytes below the base pointer, we have nothing, 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 nothing. And then if you want to print it as a string, the base pointer 13 bytes below the base pointer, you would get here. Okay, so basically, I just set you guys up for a lifetime, and you can do this for the whole code, literally the whole code I gave you. And when you're viewing it in memory, you could do this for all the way until it finishes. And by doing that, you'll just learn more, okay? So if you do that, congrats to you. You'll learn a lot from doing it, but the objective today is to find the bug. Okay, so I already spot the bug. I don't know if you noticed it, but let's go to, so right, OXD, right, or the base pointer, 13 bytes, 13 bytes below the base pointer has 000, and the memory address is DB13, right? So let me actually add that. You want to add that also so you know where. So that's 1, 2, 3, 4, DB13, DB13. This is the memory address. Okay. All right. Boom. Now we can go to next instruction. We can still examine it too, but we already know that. Well, I don't know if you guys know 30, 30, 30, 30, 30. So next instruction. Boom. So let's do it again. I'm not gonna break everything down. I just don't have time to, but we're gonna work. I'm gonna work with you guys. So that's the next instruction. We do that, do that, we do that, we do that, we do that. That's 1, 2, 3, 4, 13. And now when we go to the next instruction and we examine the base pointer 13 bytes below, we get 30, like 30, 30, 30. And now if we want to examine the base pointer 13 bytes below for the string though, we get 000. So it's basically saying, just saying move the string 0000 into the base pointer 13 bytes below. Or move, it's not 13 bytes below, so 13 bytes below, it's saying move the string 000 13 bytes below the base pointer. So the stack grows down, so 13 bytes would be 13 bytes up. If that's a little confusing, you guys need to go, I'm gonna provide a decent book. This book right here, it'll set you up for a lifetime if you understand computers, okay? So go read that. It's a great read, and yeah. So that's for that. Now let's go to the next instruction because I believe that's this move bytes. Let's just examine it. I don't know. Let's examine it. Okay, it has something in there. Let's see what that is. It's give nothing. We could also do four strings, right? We could print the four strings. There we go. We have four strings. You see there's a string below. Where the fuck that is. We do next instruction. We do base and then we do 9. And now it has nothing there. Okay. So now when we look at this instruction, move L, this string right here into 13 bytes below the base pointer. Let's we do that base pointer. Let's see what the base pointer. Let's see what's currently held in the base pointer right now. Okay, so we have 0000 in the base pointer. How do I know that? Because as you can see, okay, that was not meant to be. What the fuck? Ain't no way. Ain't no way. I just fucked up my. Alright, so we have 0000, 4 zeros. That's a string that's right now sitting into the base pointer. Okay, 13 bytes below the base pointer. Alright, this instruction we're moving 10000 into the same exact memory location as where we just move 0000 into that memory location. So you understand where I'm coming from? If you don't see it right now, even though these are different, so unions, I'm moving this into this union, which is right here. I'm moving this into this union, which is right here. But when I move this into here, this is here. When I move this into here, this goes here, but it overrides this. So union is using the same memory address. As you see, 13 bytes below. No matter where I'm moving memory, or no matter where I'm moving a string, any of these strings, where I'm copying any of these strings, it's still using the same memory address, 13 bytes below the base pointer, okay? 13 bytes below the base pointer, 13 bytes below the base pointer. So when we go in here, let me set a breakpoint at let me set a breakpoint at 134, okay? So break union bug 134, and then I hit continue, refresh, right? Okay. Mind you, you guys can break this down too if you want. So it says load the effective byte into rex. Rex comes to the function, to my function, and I can move rex into RSI, which is the source index, right? And then I'm loading the instruction pointer, which is right here, into rex again, and then I'm moving rex into RDI, which is this right here. And then we call printf. Okay, so if you don't understand that, break this down yourself. I'm gonna break it down right now just because I want to see what actually happens. So the base pointer right now is what's sending the base pointer 11111. So like I said, after after copying all these strings into different union members, they all got overwritten by the last union string being copied into one of the union members. All union members use the same memory address. That's the bug right here. So we're overwriting each time I copy something into a string, into a union member, it overwrites all the other members. So the last string I copied was 111, and that's what's being used down here. And it doesn't care about any of these strings I just copied into the previous members before. So that's the quick little simple bug that was going on in the code. We can we can break down how print works as I just told you guys. So we're moving that into rex. So if I go here, right, and I go like this rex, now rex has 11111, and then we do string. Now we examine the RSI, and 4 bytes RSI. RSI has something in it right now. I don't know what that is. Zero has been hit. This is where zero has been hit. If I do that, and I do that, and I do RSI now, 11111, and yeah. So we move Rex into RSI. 111. We're loading effective byte. Let me see the effective byte. We do 1, 2, 3, 4. The next instruction. We're loading the effective byte of the next instruction into rec. So that's 1, 3, 4. So bits is going to be into recs. Mind you, RSI has 111, I believe so, right? Yeah, RSI has 111. If I'm not mistaken. RSI has 111. We're moving this into recs. So now if I do recs, we have bits. And we're moving recs into the RDI. Recs goes into the RDI. The source index, RDI, recs goes into the RDI, and then it calls this print function. And it prints bits 11111. And yeah, basically that's all it is to this video. We just debug my code, and you guys have this code too, so you guys should go along. I did go pretty fast, and I did skip a lot of things, but that's the thing. I already did this, so if you guys have not did this before, if you never debugging and wonder where, or wanna, if you never debug and was wondering how can you debug and expect memory and see what's going on and how data is moving around in your code, this is the exact way. You first you want to have, remember, the file. This is the most important thing right here. And then you want to have the layout next, and then you want to set breakpoints. You want to examine. You want to examine where everything's being moved. So just look at different registers, see what's inside the register, go to the next instruction, see what happened to that register, take note of it, move on to the next instruction. It takes time. It takes a lot of time. We know how I know it takes a lot of time because watch. Okay. Save without quitting, without saving. That's how I know it takes a lot of time. Okay. Look. Oh shit. Oh shit. Boom, 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 boom. Every line of code that I wanted to understand, I was in that debugger. It took me a couple of days. It was slow, but I was in there, right? So yeah, you guys enjoy, learn how to debug, and that's all I got for this video. Like, comment, subscribe. Thank you.